In this video, we're going to take a look at graphing a function that is a child of some parent function. So for example, our goal is going to be to graph the function g of x equals absolute value of x plus 4 minus 3. Now that obviously is a child of the function f of x equals absolute value of x, because they both have an absolute value in them. So that absolute value tells us that they're related, and it also tells us that they're both going to be v-shaped. So what I need to take a look at right now is I need to go ahead and start by creating a parent table. So I'm just going to go with my standard points, -2, -1, 0, 1, and 2, and I'm plugging them into the parent equation. So absolute value of -2 is 2, 1, 0, 1, 2. So sure enough, if I graph those points, I get a v-shaped function. So this v is just the parent function f of x equals absolute value of x. Now, looking at the g function, I know that it's going to be v-shaped, but I also know that it is translated to the left 4 places, and it is translated down 3 places. So the translation of left 4, that's going to change my x's. And the translation of down 3, that's going to change my y's. So what I can do is I can look at this parent table that I started with, and I'm going to take all of those x's and I'm going to subtract 4 from all of them. I'm also going to take all of my y's and I'm going to minus 3. Now, the left 4, keep in mind, it is plus 4. But for the value inside the function that's being added or subtracted from x, we're always going to move the opposite direction. That value, that c, works weird. So -2 minus 4 is -6, -5, -4, -3, and -2, and my y's become -1, -2, -3, -2, and -1. So I'm going to plot the points -6 over -1, -5 over -2, -4, -3, -3, -2, and -2, -1. I'm going to plot those points, going to draw my v, and that function is my g of x. That is the child of that parent function, just translated left 4 and down 3. Pretty easy. Now, in this case, I have a more complicated child, because this child is being translated right 1, but it also has a vertical stretch of 2, it has a reflection over the x-axis, and it has a horizontal compression by 1/4. So how do I come up with all that information? Well, the translated right 1 is just this -1 there. The vertical stretch by 2 is the number in front of my function, ignoring the negative sign in front of it, because the negative just tells me that it's a reflection over the x-axis. The 4 inside the function, being multiplied by my x, is the horizontal compression. Now again, just like the +4 and the -1 in this case, the 4 works a little weird. It's not going to be a compression by 4, it's going to be a compression by the reciprocal 4, or 1/4. I know that this is going to be a v-shape because this again is an absolute value function. So I can go back to my parent table, which is -2, -1, 0, 1, and 2. And again, my y's are just all going to be positive. My next table is going to have all of my stretches and compressions performed on it. So I'm going to take my next table, and since there's a vertical stretch by 2 and a reflection over the x-axis, vertical means I'm going to take my y's and multiply them by -2. A horizontal compression means I'm going to take my x's and multiply them by 1/4. So my x's become -1/2, -1/4, 0, 1/4, and 1/2. And my y's become -4, -2, 0, -2, and -4. This is the table which is the result of all of my stretches. Now, I still need to make another table which would show all of my translations. So from this table, I'm going to create another one. Now only my x's are changing. I'm adding 1 to all of them. My y's are staying the same. So my x's would now become 3/4. Oh, excuse me. That first one will be 1/2, then 3/4, then 1, then 1 1/4, and then 2 1/2. And my y's are all going to stay the same. So they're going to remain at -4, -2, 0, -2, -4. This end resulting table is going to be how I'll make my graph. So I'll go back up here. I'll graph my points at 1/2, -4. So we'll go 1/2, then down 4. That was at -1/2. I want that to be a positive 1/2. The next point is at 3/4, -2. So 3/4, -2. The next point is at 1, 0. And then I have a point at 1 1/4, -2. And I have another point at, if I look back here, this should have been 1 1/2. So at 1 1/2, -4. So I end up with a very skinny absolute value graph. It has been reflected, it's turned upside down, it's been vertically stretched as well as horizontally compressed, and it has been translated right 1.